We are Group B of the Digital Wireframes workshop. Our project is called Butterfly. What we've been exploring in the past 4 weeks is the relationship between unit and system. We started with playing with PianoWare. We made a lot of units and classified them by motion behaviors, number of orbits, etc. In the end, we chose this one. It is made of 2 continuous PianoWares with 4 sliders, 2 of which are flexible. What we do is to move them into different directions to see how units change. We found that those 2 sliders can move to same direction or move to opposite directions, which create a wide range of sizes of single unit. After making the physical model, we simulated 2 different behaviors in Grasshopper. After the units exploration, we started to explore the different relationship between units. We add some other components on unit or array them in x-axis, y-axis, or rotate one of them in 90 degrees to see how those combination works as a primitive system. In the end, we chose this one, array the unit in x-axis. It is the most simple one. To be more clear, we use the different colors to classify sliders by positions. The white and black are the connections within units. The blue one is the connection between units. And then we started to create system by connecting 2 units. By changing the slider's position in same direction but different distance on PianoWares, we can see the 2-unit system change its length in both axis and y-axis. After the 2-unit system, we try to develop bigger system by adding another 2-unit system. And then we keep arraying the 4-unit system in x-axis or y-axis to create bigger system. The whole system can be deformed by inner sliders and outer sliders. In this animation, you can see we are changing the outer sliders' position. When we push them close to center point of unit, the whole system is extracted. In contrary, when we push them far away from the center point of unit to the terminal point, the whole system is expanded, obtaining longer distance in x-axis. In this animation, you can see we are changing the inner slider's position, same as the outer slider's position. When we push them to center point, extracted. When we push them away from center point, expanded. But different from changing outer sliders, inner sliders change the whole system in a smaller scale but staying in a more stable status in the end. We also try to move each line's inner slider's position into different distances. In this case, as you can see in the animation, the 2-dimension system can become a very different shape, for the reason that inner slider's position take responsibility of system's length of x-axis. Outer sliders can not only change system's length but also change the radius between each unit. When we push outer sliders' position into different directions, one of them to center point, another of them away from center point, you can see the angle between units changing from 180 to 120 or even smaller. By controlling this parameter, we can bend the system into a very dynamic system and status. For expanding the system into 3-dimensional system, we add another layer. Instead of arraying them parallel, we make them connect dislocated. When the system only has one layer, it is flexible. But when we add another layer, because of the dislocation connection, there is an interactive force between them, which makes the whole system more stable after moving sliders. We try to mix all the different slider motion together in one system, as you can see in this animation. We move the outer sliders into different directions to make the system bendy, and also move the inner sliders in same directions to change its length in x-axis. With all the simple operations but mixed, the simple system changed into complex and dynamic system. We catalog the final system into 4 types. Rectangle, which is the most original one. Trapezoid, which is the one only by moving inner or outer sliders into same directions. Bridge and ice type by both moving inner and outer sliders into different directions. After the simulations, we made each type's physical model to test if the simulation is correct. Turned out they all work in physical models. We tried to explore further by creating the system into a closed geometry, which is also a bigger system. In this system, we moved the inner connection, outer connection, and also tried to close the surface in order to creating a more flow system, and we made it. We changed the parameters dynamically, and with the slider's position change, the system changed dynamically. Here is another system we explored. In this one, we limit the slider's types and its motion. In this case, we can only allow outer sliders moving into opposite directions. In the simulation, each of unit is bended into a limited angle with adjacent one. Although the final system looks the same as the first system, it is not that flexible. After all the research we have done in this project, we gradually understand how to control the relationship between unit and unit, and how to modify the partially relationship to influence the whole system. I especially want to thank our tutors for their support and my fellow teammates for their cooperation. Thank you.